Hello everyone. In my last video we have covered singly linked list. You can find the link of playlist in the description box of this video. So today I will give you introduction of doubly linked list. Doubly linked list have two pointers to navigate forward and in backward directions, whereas singly linked list have only one pointer, or you can say link, to move only in forward direction. So in singly list where a node have one pointer to the next node, but in doubly linked list we have two pointers, one to its previous node and one to its next node, thereby giving us a way to traverse in backward direction also. Now look at the structure of doubly linked list. Here I am creating three nodes of doubly linked list. Each node is divided into three compartments. Middle compartment is for data. First compartment is the link to the previous node. And third compartment is the link to the next node. X2 is the address of the next node, X1 is the previous node, and for this we have X3 next node, and for the third node we have X2 as previous node and null to its next. This is our head node or start, and in doubly linked list we have one data field, two pointers, one is the link to the previous node and a link to the next node, right? Link for next node and for previous node. So we have a structure like this: class node where we have one data field like we have in singly linked list, and here we have one for the next node and one link to the previous node, right? One drawback of the doubly linked list here is that we have a overhead of one extra pointer here. In each node we have to save a link or a pointer extra in comparison to the singly linked list. Now look at the various operations that can be performed on doubly linked list. They are same as singly linked list. So first is traversing. Here we can traverse in forward as well as in backward direction. Second operation is insertion. We can insert a node in the beginning or in the middle or between the two nodes means, or at the end of the list. Deletion, same three possibilities: in the beginning, middle and end of the list. And we can perform searching operation as well. Now let's start the operation. We will start with traversing a doubly linked list. If you know how to traverse in singly linked list, which we discussed in the previous videos, then you will find a lot easier to understand traversing in doubly linked list. Here I am making a doubly linked list with 3 nodes, and let's traverse them in backward and forward directions through an algo. So here we have 3 nodes. Data field is 5, 10, 15. This is our head or start node. Its previous field is null as there is no previous node in the start, and the next field points to the next node, and the last node next is null. So this is our doubly linked list. Let's look at the algo of moving in the forward direction. So in this case, mark current node. This is our pointer, current node, or we can say it's current. So mark current equal to start, right? Now we have to move current to next until current will become equal to 0. So second step, we have to repeat some steps until current becomes null. Okay, so what are the steps? They are display. First we have to display the information part, means display current dot data, and then we have to move the current to its next node in the sequence, current dot next, right? So these are the steps to move in the forward direction. These are same as singly linked list. And in backward direction, what are the steps? They are just like same, where we can mark the last node by traversing in forward direction, or you can put a pointer last, like we have start for the start of the node, and we can have a last for the last node. So first, either you have a last node, or you can mark current as last, right? Now for this case, we have current equal to last. So again we have to move current in the backward direction, so we have to repeat until current becomes equal to null. Same condition, because head node previous is also pointing to null. So we have what are the steps to repeat? Display data in the current node. So display current dot data, and second step, we have to move current in the backward direction, means current will equal to current dot previous, right? So this will lead to current now pointing to current dot previous, means it will go in backward direction. So these are the only steps to move in the backward direction. You can find the full program of doubly linked list in my website seekyourcareer.in. You can find this link in the description box also. So thank you guys, see you later.